video that there are different properties in different groups on the periodic table. Like these were our alkali metals, and they were also often shiny, and these are alkaline earth, and we had our halogens, we had our noble gases, we had our transition metals. But one thing we need to know is there aren't just random changes as we go across. There are actually specific changes, specific properties you can track as you go across the periodic table and as you go down the periodic table.
Oh, okay. Well, what would be an example of that?
So an example of that is electronegativity.
That's a really big word. I'm not ready for this.
Yeah. So electronegativity simply means how hard they're going to pull on their electrons and how much they're going to try and pull them from somebody else.
Okay, so they're trying to scoop up electrons.
Right.
Okay.
So our electronegativity increases as we go across over to fluorine and down, and decreases as we go down. Fluorine's our most electronegative element. It wants all the electrons.
So why would it increase going across?
Well, as we go across, we look at our numbers. So we have these numbers here. What did those mean?
I think I learned that those were protons.
Those are our protons. And what charge do protons have?
I remember it started with a P. Protons are positive.
Protons are positive. And if our protons are going up, what else is going up?
How much pull they have?
How much pull they have. So they're going to attract our negative electrons because opposite charges attract.
Oh, plus and minus attract.
Right.
Okay.
So the electrons are going to get more pulled in as we have more protons.
So that makes sense why that would get higher going across, but that makes no sense about going down the group, because look, there's 9 protons on fluorine and 85 down here.
Well, part of that is because we haven't really talked in detail about the structure of the atom. We talked about the electrons are outside the nucleus, but not more than that. What it is as we add more electrons, we also add more levels of electrons that keep stacking.
So the electrons are further away?
So it's a lot harder to, so it's like having 2 magnets that get too far apart.
Okay, so you can't pull them in. Okay.
Right.
All right.
And so another property we have to think about is ionization energy.
These are all huge words. What's the deal?
They really are. Scientists like big words.
Okay, ionization.
Ionization energy. So we know what energy is.
Yeah.
How much energy it takes to do something. Ionization, do you remember maybe from middle school what an ion is?
Isn't that when it's like charged or something?
Right, so if things have a charge, it's because they've lost electrons or gained electrons. Right now, we're worried about losing electrons. So if something really, really wants its electrons, it's got high electronegativity, is it going to take a little bit of energy to pull an electron off or a lot of energy to pull an electron off?
Well, if it really likes electrons, it's going to take a lot to pull
Right.
away.
So if you can remember about electronegativity, ionization energy isn't that complicated because electronegativity increases going across, so it makes it harder and harder to pull off electrons. So our ionization energy is also going to increase going across and decrease going down.
So they're pretty much the same, it's just a different way of looking at it.
Right, because so electronegativity is looking at how much it's pulling the electrons in. Ionization energy is looking at how much energy it would take to take them away from them again.
Okay, that makes sense.
All right. Another one we have to worry about is atomic radius. So you should know radius from math.
Yeah, isn't that like the part of the circle, like just the part from the center to the edge?
Mm-hmm.
Okay.
So atomic radius looks from the center to the edge of an atom.
Okay, that makes sense.
So it's how big our atom is. So we said our electrons get pulled in tighter and tighter as we go across, right?
So if they get pulled tighter, wouldn't it get smaller?
Right. So our atomic radius decreases going across because our protons are going to pull our electrons in. So as we go down, what do you think is going to happen?
Well, you said that they get bigger because we have more energy levels, so they're going to increase.
Right. So atomic radius decreases going across and increases going down.
Okay, I got it.
All right. The other one we have to worry about is ionic radius. And this one's a little bit weird because funny things happen. But what you need to remember is if we make a positive ion, what would have to happen for us to make a positive ion?
Well, can we get another one of those protons?
We can't get any more protons because we change atoms.
What if, I learned in math that if you take away negatives, that might make it more positive?
Right. So the only thing we can change about an atom is its electrons if we're just trying to worry about ions. So if it loses electrons,
it's losing a negative.
It's losing a negative. So is it going to pull in tighter or is it going to get bigger?
I think it would pull in tighter.
Right, because you have an imbalance between your protons and your electrons.
Yeah, an extra proton and it's pulling in.
So anytime you've got an ion that's positive because it's lost electrons, it pulls in tighter. It gets smaller than the atom it was made from.
Okay.
So if you go the other way, you make a negative ion because you add an electron,
So it's going to get bigger.
it's going to get bigger.
Okay.
So negative ions are bigger than where they started, positive ions are smaller than where they started.
Is there a way to tell on the periodic table if they'll be positive or negative?
It gets back a little into what we talked in the last video about valence electrons. If they've got just a couple of valence electrons, like most of our metals, they tend to want to lose them, so they make positive, they tend to get smaller.
Okay.
Here, they've got most of their valence electrons, these have 6, these have 7, so they're going to want to pick up a couple. So they're going to get...
They're going to get negative, bigger.
Right, so they're going to get negative, they're going to get bigger.
Okay, I have a really important question though. Like, we're looking at fluorine and you're saying as it goes across, but why are we not looking at helium?
We're not looking at helium because remember we talked about noble gases?
They're very snobby.
They're very snobby. They want to hang out by themselves. And pretty much all of these things you can measure, you have to measure when they're in a compound with something else. So if they won't make a compound with something else, we can't measure these things.
So when we're talking about these trends, should we just pretend that it's not there?
We pretend they don't exist. It's not going to change.
Okay.
It's not going to follow the trends. The only thing they will follow is atomic radius. Because those do have sizes.
Okay, so let me get this straight. Metals are over here, and they're going to probably be positive, and non-metals are over here, and they're probably going to be negative, and we just don't even really worry about the noble gases.
Right.
Okay.
So the biggest thing you need to remember, we said how that fluorines are most electronegative. That's the point to focus on. But the other thing to remember is down in this bottom corner. How you can remember all of your trends is large, low, low.
Okay, it's a large atom.
Large atoms are a large atomic radius.
And we said the biggest electronegativity was here, so that would be the lowest.
That's our lowest electronegativity.
And the ionization energy was the same. So
Right.
low.
Ionization energy is also low.
Okay, got it.
All right, so let's recap the trends that we just talked about. The first one that we're looking at is electronegativity. And as we go across the periodic table from left to right, it's going to increase. As we go from top to bottom, it's going to decrease. With, let's get a different color, with ionization energy, it's going to follow electronegativity since they're so closely related. So ionization energy, as you go across, is going to increase. And as you go down, it is also going to decrease. Atomic radius, as you go across, is from left to right, is going to decrease. They're going to get smaller. And then as you go from top to bottom, you're adding the levels, so your atomic radius is going to increase. And then the very last one is our ionic radius, IR, and as we go across from left to right, again, the atomic radius is going to decrease as we go from left to right. And as we go from top to bottom, it's going to increase. A good suggestion would be to get something like this in your notes copied, drawn out, so you can see all the trends kind of put together, so you can see what's going on.